The 4E notes are about function patterns. A linear function is one whose graph is a non-vertical line or part of one. It has a constant rate of change. So let's look through example 1 and talk about which of these represent a linear function, and if not, explain why. So 1, yes, you see it's a straight line. 2, it's curved, so this is not, so this is yes. The second one is no because it's curved. The third one is yes, it's a straight line. And are they functions? Yeah, for every x, is there only one output? So yes, these are also functions. This is not a linear function because it's curved. This fourth one here is a straight line, so it's a line, it's linear, and for each x there's only one y, so yes, it is a linear function. And this last one, the answer is no. Why? Is this not a linear function? It's obviously a straight line, but for each x, and there's only one x, oh look, there's a multiple y's there. So for each x, there's many y's, so that is not a function. It may be a line, but not a function. All right, so example 2 says determine if each table of values represents a linear function. Represent each with a graph, and if linear, words and an equation. So let's just start off and graph this below. So we have the point 0, 2, so 0, 2 here. We have the point 1, 5, so over 1, up 1, 2, 3, 4, 5. We have the point 2, 1, 2, 3, 4, 5, 6, 7. Well, we're going off the graph. And then we're going to have the point 3, 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you can kind of see that this is going to end up being a line. So I'm just going to stop it right there, but it is a line. So now let's take a look at the table and talk about the fact that there is a constant rate of change. Notice that going from 2 to 5, that we add 3. So here to here is plus 3. And then to go from 5 to 8, 5 plus, again, plus 3 is 8. And 8 plus 3 is 11. So, and over here we go 0, 1, 2, 3. So it's stepping up in ones. So there is a constant rate of change. It adds 3 every time. If I were to write this out, here I have a 2. Here I have a 2 plus 3. Here I've got the 2 plus 3 that I had above it, plus 3 more. And, well, I'm not writing these in the right place. So this goes here, this goes here. And then the 11 is going to be 2 plus 3 plus 3. What's above it? Then plus 3 more. So that's kind of the way it's setting up. So we start off with a 2, which is going to be our constant part of it. Then we're going to add 3 each time down. So notice that when x is 0, I add 0 3s. When x is 1, I added 1 3. When x was 2, I took that initial 2 and I added 2 3s. And when x was 3, I took that initial 2 and I added 3 3s to it. So our equation is going to be that our y is going to be equal to 2 plus 3 times n, or x, I should say x there, 3 times x, where x is this over here. So if x is a 0, I get 2 plus 3 times 0 is 2. If x is a 1, 2 plus 3 is 5. If x is a 2, 2 plus 6 is 8. So you can see how that works. So this would be the equation. And I'm going to say for each increase of 1 by x, y increases 3.